So I'm glad to welcome Professor Liviu Dinu of the University of Bucharest, and Doris will introduce him.
Yes, so I had the pleasure of meeting Professor Dinu in Oxford early this year, where we are, I suppose, both enjoying both the Conference of Historical Linguistics and the local beers in Oxford. So apart from being a professor of the University of Bucharest's Computer Science Department, Professor Dinu is director of the Human Language Technologies Research Center and member of the Computer Science and Interdisciplinary Doctoral Schools over there. And he's currently the PI of the project Cognate, which stands for Computational Tools for Historical Linguistics. And I expect that much of the topic, the subject matter that he will discuss today is in the spirit of this project. So without further ado, I will give the floor to Professor Dinu, and he will be talking to us about computational tools in historical linguistics for cognate detection, borrowing discrimination, and proto-word reconstruction. So the floor is all yours.
Okay. Thank you, Doris. Thank you, John. Thank you for your invitation, and thank you for your presentation. I try to share. Okay, it works. It works. Okay, so
Yeah, it's yeah.
It's okay. Thank you. Okay, as Doris already said, we work in the computational approaches of historical linguistics. So we have either more than 10 years, and I present here in this presentation. We have also new results and older results which we obtained before the funded our project starts 2 years ago. Some of the references or main references for this talk are listed here. There are a few works from appeared in the Computational Linguistics in the journal, the recently one from EMNLP from last year, and regarding the automatic Latin proto-word reconstruction paper which we published in 3 years ago. And we have also recently works in semantic divergence in the but I haven't time to talk about the semantic divergence in this talk, but I list here, and more papers are listed on our the web page of our project. Well, why do we have to investigate the behavior of natural languages? Because the natural language, the people are living people. Okay, they fall in love, they hate the people, like to talk, to travel, and so on. And by consequence, the natural languages are living ecosystems. They are constantly in contact. The people is in contact, and they change continuously. Borrowing is one of the biggest problems in historical linguistics. Why the language borrow? Campbell said certainly that people like to borrow words primarily because of need and prestige. No, maybe you know, in all the world, not only Romanian, is cool to use English word when even if you have the same word with the same meaning in your language. Traditionally, there are two big questions in historical linguistics, namely how are languages related, and how do languages change across space and time. Actually, in our talk, we try to talk about the second languages. I add here a third question, what and how do we measure, which is mostly related with the computational approaches in historical linguistics, because to have an idea about a good approach for the historical linguistics, we have to say to tell to the machine what and how do we and the machine measure. I like some years ago in the workshop at ACL in 2006. I remember it was a very nice workshop regarding the linguistic similarity, and there Nerbon Hicks, and I completely agree with them. They talked about the fact that there is always a hidden variable in the similarity relation, but I can say that not only in the similarity relation, in the languages relation, and we have always to talk about similarity or the problem which we investigated with respect to that property, with that hidden property. I think that always will be nice to work, especially in our interdisciplinary research. I came from computer science. Always is better to work with the people from linguistics and to try to see which exactly they need. They don't want to use the computational tools as a computer scientist, but also like a linguist, and they need explanation at the explanator. The historical linguistics, traditionally the problems have been investigated for centuries with the comparative linguistics instrument. And the main idea is to perform a property-based comparison of multiple sister languages in order to infer properties of their common ancestor. The rotachism is one of the which I like, the main tool which they use. Of course, this is a time-consuming manual process that requires not only a large amount of intensive work, but they need also a lot of people, and all the people need have to be before need the school, need training, and so on and so on. Recently, I don't know, maybe it's the more recently references, but is the most recently which I found. Campbell and Haggard, especially in 2012, suggest that in principle, the borrowed words, the borrowing must be identified and excluded before the comparative method can be applied. It's not easy to, could be problems when we analyze borrowing, but in fact we need cognates pair. At the same time, they admit that this is sometimes easier said than done, and they argue for the use of computerized approaches in this field. As Doros already said, that I was very happy to see that at ICHL conference from Oxford, I don't know if it was the first, anyway, but was for the first time one day they like to use the computational approaches in historical linguistics. They accepted an entire workshop dedicated to this field. The quote which I used is it's this paragraph which I find in the Haggard, in the volume dedicated to Swedish, when in fact they accept Haggard, from the linguistic point of view, they accept that maybe it's the time to accept the computational tools and approaches in classical linguistics, in classical historical linguistics problem. Said before, and I try to explain our idea or our approach, and I completely agree with the list and Simon Greenhill, the slide I found for the first time in one of their presentation. I think that the best is to have always work to integrate expert knowledge, which comes from pure linguists, and computational power, which comes from people from computational linguistics. I think that the best results comes if we don't take into consideration approaches, either computer-based or classical approaches, but better, I think in the computer-assisted approaches. From our point of view, from computer science, probably the best is to give a filter, to give a tool to pure linguists, to classical linguists, and they analyze if it works or not. If they find something good or something problem, they change their role and switch. This is the way in which we work in our project. Always the discussion and interaction with the people from linguistics. The solution and some of the main challenges which we attack in our project in my presentation are listed here. So we try to solve some problem regarding the identification of related words. Namely, given a pair of input words, we have to identify the relationship between them. Namely, if two words are cognate, if one is borrowed from other, if we have a cognate or borrowing pair, if they are cognate or borrowed or inherited, or there are no relation between them. We can see here. I present here some pair of words from Italian and Romanian, Portuguese, Romanian, Spanish, Romanian, and Turkish and Romanian. Here is the borrowings. Balletto, ballet for ballet, macchette, macchetta for machete, tutun for tobacco. Borrowing, if we are looking at the surface form, there are no big differences than the cognate form, which we have here. Victoria in Romanian for victory, instinto, instinct for Portuguese, Castillo, castel for castel, and so on. Actually, at the first view, more or less, it's not easy to say which one they are borrowing and which one are cognates. And in the first part of my talk, I try to present our solution in this problem. The second part will be dedicated to Latin proto-word reconstruction. So this means to recreate the words in Latin in ancient language, from its modern Rota languages. We work with Romance languages. So given the modern form in Romanian, Italian, French, Spanish, and Portuguese, we want to see if we can reconstruct the Latin proto-word. Sometimes it is a very hard problem because the words change their form drastically in the future. For example, we want to see, for example, for the umbilicus, nombril in French form, buric, Romanian form, or umbigo, there are completely different forms. It is possible to obtain the Latin words umbiliculus, which is the word for umbilicus. It is not easy. And the third challenge, and I have probably not time. If I have time, I will say a few words, is about the semantic divergence, which will be actually next year we want to work in the semantic divergence. We work with I put here some definitions. For the cognates, we use the classical definition, words in different languages with the same meaning and a common ancestor with the same etymology. For a borrowed word or loan word, words adopted from one language, which is the donor language, in the other language in the recipient form. And for the inherited words, we use the definition from here lexemes that have been preserved from the mother tongue in the vernacular languages by uninterrupted oral usage, which is very linguistics definition. But before to start with our challenge, with our solution, we realized that one of the big problem are the data. One of the big data, the big problem is the data. Okay, the problem is that not that there are not so many data. There are many data. There are many database in research, but always we have some of the problem. The data are scattered. They are incomplete, or the data are with uncertain availability. A lot of paper use data from a dictionary, which is okay, it's a good resource, but with probably not very careful investigated. So before to start or to try to solve the problem, we start with step 0, and we focus on creating clean data sets via various computational tools, and with a huge computational force. And then we corroborated with the work of our friends from classical linguists. We built a database of cognates between Romanian and all the other Romance languages. We use for this idea, we use the electronic dictionary, and via this electronic dictionary and via our approach, we said, okay, probably we obtain almost all the cognate pair between Romanian, like one languages, and all the other languages. And actually, we are almost ready to finish the same work for all the other languages. Always we keep one language as source languages. We try to obtain the cognate pair from that languages in all the other languages. There are some probably errors. So we identified the errors, but and the errors were the errors which we obtain when we create this database, is the Cognate database. Probably no time to explain all the steps, were around 2 or 3%. We obtained here, we see here the results which we obtained. Actually, between Romanian and French, Italian, Spanish, Portuguese, and Turkish, here is the number, the total number of words. We obtained, for example, more than 3,000 cognates pair with Italian, more than 5,000 words pair with Spanish, almost 10,000 with Portuguese, 2,000 with more than 2,000 with Turkish. But we have, you will see here, we obtained only less than 500 cognates pair with French. This is a little bit surprising, but it's surprising because we use the definition for cognate words in different languages with the same meaning and a common ancestor, but and for borrowing always the words which with that word like etymology in the languages. But a lot of words in Romanian, they have a double or multiple etymology, and one of the etymology is given is a French etymology. So we see that we have more than 50,000 etymologies borrowing words from French. Anyway, we have for the moment this huge database clean and checked by the our friend, by the linguists, which we start to solve our problem. So Given this database, we start to solve the main challenge, namely the identification of or identification of related words. For the first time, for the first step, we try to solve the problem of cognate identification, namely given a pair of words, we want to see if it is possible to say if they are or not cognates. We have a lot of application of cognate identification. I listed here a lot of research area where the cognate is good to know. So we start with the identification of cognates. Our methodology, our approach was more or less to mime or to we copied the work of classical linguists, which it worked okay for many years before. The first step in our approach was to use a aligning algorithm and try to align the pair of related words. After the aligning the words, we go for the second step to extract the features from the alignment. And the third step was to use some algorithms, some machine learning algorithms to identify the class if they are or not cognates. Okay, I will explain the idea behind the step, each step in part. For the aligning part, we used the Needleman-Wunsch global aligning algorithm. Okay, we can say, okay, this is old aligning the algorithm from 70s, the last century. The Needleman-Wunsch, it works okay. He was invented for the bioinformatics. In bioinformatics, okay, we have problem because the chain could be very large, and maybe the Needleman-Wunsch algorithm, the idea doesn't work because of time or necessary resources. But in linguistics, the words, the strings are not so huge like bioinformatics. We talk about words with probably no more 20 characters or something anyway, no greater than 50 characters, and with the force of the present computers, we can work with this type of strings. I have to say that we try also with various other algorithms, aligning algorithms, and the differences were not significant, statistically significant, and we decided to keep the Needleman-Wunsch algorithm till the end. Here is a example how the Needleman-Wunsch algorithm works. Probably you already know. If we use the function words funcție Romanian, function Spanish, the alignment given by our algorithm is like here. We decide because we have to keep in mind that the beginning of the word or the same character has a various different behavior at the beginning of the word, inside of the word, or at the end of the word. So we decide to add some markers to have an idea finally if the character which we use and we investigate in the feature is from the beginning, from the end, or from the middle of the word. So this is why we decide to use a marker at the beginning and at the end of the word. One of the problems I have to say here with the alignment alignment was that okay, like all the computational algorithms which talk about the best no, which minimize something. Okay, we have not only one alignment. We could have many alignment, many alignments, and we have to choose one because the cost is the same, is the minimum cost. Okay, we have to choose which is the best when we have not only one alignment. We our solution, which was I don't know, a pragmatic one, because till the end we haven't a clear explanation why. We said, okay, we will choose always the first alignment which the algorithm offer us. On the other hand, we look manually at how many alignment do we have, do we obtain via this Middleman bunch, and sometimes we obtain only one, but usually we never obtain more than 4 or 5 alignment. The second step was to choose to extract the features from the alignment. Our solution was to, and the best solution was to extract features like the features are n-grams, and 1, 2, or 3 of characters around mismatches in the aligning words. So the mismatches in the alignment word are here T, and we have here a deletion. Here we have a mismatch E and O, and an insertion here, and all we consider, we take in consideration all this type of misalignment. So, for example, the big grams, the big grams which we used for this case are CT and C. Dash TI and dash IE IO E dash ON dollars dash and dollars. So here is clear. We decide to take in consideration to use all these features. Like algorithms, we use the naive Bayes and support vector machine HVM. At the output, we have to decide if we are in the if we have a cognate pair or not, binary solution. Some explanation about the computational force, and here is the dataset which we used for our experiment. The pair of languages are the languages and the dataset which I explained, I show before: Italian, Romanian, French, Romanian, Spanish, Romanian, Portuguese, Romanian. We take the same number of pair of words, so we decide to use 800 word pairs for each languages, 400 cognates, and 400 word the pair of words which are not cognates. We choose 400 because for French and Romanian we have less than 500 pair of cognates, but with the form with the definition which we use. Anyway, with via the steps which I explained, I showed before, we obtain here, you can see accuracy around of 87% for French, 81% for Italian, 86% for Spanish, but only maybe 73% for Portuguese. So the best results which we obtained at that time was for the Spanish and the French with around 87. Then we went curiously, why do we obtain so why do we have this difference between Portuguese and the other languages? Always the SVM produced the best results. When we made the error analysis and when take a look at the words, the pair of words which were misclassified by our algorithm. But in the case of Portuguese, we saw that actually, in a way, maybe the machine, the algorithm was not so wrong, because they misclassified more non-cognates as cognates than vice versa, but with our definition. So they find actually with Portuguese, they said, okay, this pair of words, they are cognates. But when I look at their etymon, we saw, okay, they haven't the same etymon. But for example, maybe one word comes from French, from Portuguese comes from French, and the Romanian comes from Italian. But when I look at a deeper level, we saw that both the etymons of the initial word from French and Italian, they have the same Latin etymon. So actually, our words, they were more remotely related words, and this is why our algorithm didn't label as cognate. So the machine, in a way, so observed that our pair of word, the initial word, in case of Portuguese, they are more remotely related. And if we can use probably in the future, we'll use a extension or definition of our cognates. If we say, okay, if we use the definition, okay, if even if they have common ancient, but not exactly at the first level, even more remotely, we obtain better results also, and with the accuracy our intuition level will be will increase. The second step was to see if there are a difference between cognates and borrowing. It is possible to decide if a pair of words, they are borrowing or cognates. Before I showed the table with manually, is not always so easy to say ballet to ballet, Victoria. There are no big differences, which is borrowing, which is cognate. We decided to use the same strategy we used now the same data, but we used 2,600 pair of words for each languages. Why? Because we have 1,000 and around 300 pairs of borrowing between Romanian and Portuguese. We use the same algorithm, Niedermann-Wunsch. We use the same idea of features, but we changed something in the features. Namely, we decide now, and because it was an empirical study, and we obtained the best results when we take in consideration all engrams, not only around mismatches. So even the engram when we haven't changed in the word. The best classifier was SVM with radial basis function kernel, anyway, and the results are presented in this table. We obtain accuracy around 70% for Italian and Romanian. For Portuguese, 90%. For the Turkish, the same 90%. For Romanian, Spanish, 85%. This was the first idea when we try to see if there are, if we want to say if a pair of words, they are cognate or borrowing. But we said later in the second table, okay, but we are in the there are in the other situation. We have a pair of words which are neither cognates, neither borrowing. There are no relation between them. In the first experiment, we know a priori that the pair of words are cognate or borrowing. But we add the third class and we said, okay, in reality, we have three situations: cognate, borrowing, or there are no relation between words. And as we our expectation was the accuracy decrease a little bit. For example, for Italian or Romanian, when we use three classes, we obtain 63. For Turkish, 86, 77 for Portuguese, or 74 for Spanish. So in the real case, with three classes, the accuracy which we obtain is for the moment is that one. If we are looking at the error analysis, so we can see that, for example, for Portuguese and Spanish, the lowest performance was obtained for unrelated words. When we have there are no relation between words, and in both cases, our algorithm mistakenly identified the cognates than borrowing. They are more often like cognates than borrowing. For Italian, and remember the task of given by Hegarty before, and others. For Italian, for example, borrowings was the most difficult class to identify correctly. For Turkish, instead, was the cognates was the class more difficult to identify compared to other classes. So there are differences between the languages we see here, and probably will be nice for this kind of research to take one by one each language in part. We try to see if by adding some linguistics factor, we obtain a better results. We try to add post tags, hyphenation. I have to say that always we look at the graphical form of words, stems, diacritics, or if we take in consideration only consonants, and if we delete the vowels, if we can obtain better result. Some of them, they have a little bit, they improve a little bit the results, but actually no one give us significantly, statistically significant results. So, regarding the third task and the last one, which about I talk on in this first part about the inherited and borrowed words, we take in consideration here the data from Wiktionary for Italian, Portuguese, Catalan, Spanish, French, Romanian, and for Romanian we take in consideration not only the Wiktionary, but also the the whole Romanian dictionary text online. We take in consideration now, and we look. The idea was the same, with aligning the same strategy, the features, and we use the various algorithms. But in this situation, we looked also at the phonetical form. One of our surprise was that if we see here, the phonetical form of the pair of words obtain more or less the same results like the orthographical form, but in the many cases even small, even lesser results. We see here the results. Anyway, we obtain the best was with SVM and with information given by Etimons. We obtained around of 90% accuracy for the discrimination between inherited and borrowed words in Latin languages. However, when we use the entire dictionary of Romanian dictionary, we see that we have results improving. We improve the results with around of 3%. So the best results are for, in this case, for the phonetical form, around 94% discrimination between inherited and borrowing word for Romanian, and was the best for the phonetical form, but with not so big difference versus the orthographic part. Okay, so I finish now. I want to be in time. The first part regarding the discrimination between words, and I want to present now the second challenge of our project and our team, which is about the word production. So we start with the Latin protoword reconstruction. So already said, given input words in sister languages, in N languages, we want to produce their common Latin ancestors. Our work was based on the modern Romance languages, Romanian, Italian, French, Spanish, and Portuguese, and we want to obtain, to see if it is possible to obtain the proto-word, the Latin proto-word. Okay, various possible approaches. Now we can vote if nombril plus buric plus umbilico is umbilicus. We can vote for the century, the comparative linguistics instrument. The method was the best method, and we want to see if via our method, our computational approach based on machine learning or modern technologies, we can obtain better results or competitive results. Of course, the computational methods need data for training. We have to say that our golden solution, our best idea was to combine, to try to obtain a combination and to aggregate the results which we obtain when we apply the same algorithm on every language, on each language, on only one language. So if we apply the one algorithm and we decide to use alignment method and then to apply a CRF algorithm, and we apply this methodology on French, on Romanian, on Spanish, on Portuguese, in part in each one, that's only one languages, we obtain good results, but actually we weren't state of the art. But when we decide to combine, to use an ensemble of method to combine the results obtained by each language in part, our surprise was that okay, we're happy that we obtained better results with good results, and in a way we became okay, we surprised other results before us. So here is the methodology. Our idea was to start with data from modern languages. Then we decide the sequence alignment. Finally, we decide we obtain the same Niedermann-Wunsch algorithm work was the best. Even here, we try with various other alignment method, and finally we decide to keep the best one, the feature extraction, and we apply CRF inference. So this was the step for each language in part. And finally, we decide to apply the same for each language in part, and then to combine finally, because we obtain output sequence for each sequence, for each language in part, and we decide to apply one ensemble which we define in our strategy, and finally we obtain better result. Okay, the alignment is the same. In CRF, we need, to have a label for each character from the first string, and we decide when we have a deletion, when we have an insertion, to make a label between the insertion and the previous characters which we have before. So this is the label which we have here for beautiful Frumos or Formosos, Romanian, Spanish. F goes in, is labeled with FO, because we have here an O, which is an insertion in the Frumos to obtain the alignment. U is delete, and the last one is when we have the E, the final begin end of our we use here, like in cognate identification, we mark the beginning and the end of the words with, in this case, with different symbols, with B from begin and the E with end finally. So this was the training and computational approach. The labels and the features, we talked about it. About them before. Features are character engram from the input word, so we use in this case also the engram. The label I already talk about it. When we add in case of insertion, the character we link with the character we do previously character. And what talk was about ensemble. What kind of ensemble do we use? It will be easy to show on this example. For example, when we use, we have this example for the French, for the neighbor Bassin, Vicinus, Bassin. We see that when we apply the CRF, our algorithm, but only for the one languages, the proto-word, the Latin proto-word, which is Vicinus, doesn't occur in the first production which we obtain. So for Bassin, the Bassin is the modern word in French, and when we try to obtain the Latin proto-word, we see that in the first, which ranked from the beginning with the highest probability to the fifth one, with the highest probability, the Latin proto-word doesn't occur. For the Italian, Vicinus, we see it is occur on the second position. For Portuguese on the third position, for Spanish on the fifth position, for Romanian on the third position. When we apply our ensemble algorithm, we see that we obtain finally the ensemble. We combine all the words. The Vicinus, the proto-word, the Latin proto-word, occur. We obtain it on the first position. Our idea to use the ensemble was to compute actually average rank for each position of each word which we have, and finally to use in the kind of border situation, border ensemble, to count all the position which we have and the number, and finally to obtain a new classification, but via the numbers which we obtain when we add and make also an average via all the positions which we have in each language, in every language is in part. So this was the first idea of ensemble. But the second one, which was actually the best, was a little bit change. And we said, okay, when we made comparison, we can see that, for example, for French, we have one accuracy, a kind of accuracy. For Italian, maybe we have a different accuracy. For Spanish, a different one. And for Portuguese, different one. So each language comes with its own accuracy, and we decide finally to take into account this accuracy, and we add this accuracy with for each position of a word in of a word in the language. We multiply with the accuracy of that languages. So this was the best results which we obtained when I take into account the rank and the accuracy. We used now 3 data sets to see the results which we obtained. The first data set was a data set used also by in the paper of Bouchard-Coté from 2007, and he offered us a round of less than 600 complete cognate sets, but only for Spanish, Portuguese, Italian, and orthographic and phonetic. And we said, okay, if we have a new measure, we have a new methodology, we have to compare with the results with the data set of Bouchard-Coté. The second one was a data set of around 1,100 cognate sets of pure linguists. The data set was Ripeanu, Sandra Ripeanu, okay, Romanian, but the teacher, okay. She offered us a list of 100, more than 1,000 cognate sets for Spanish, Italian, Portuguese, French, and Romanian. Some of them are incomplete, we have to say. And the third one was our data set, about I showed before, and we used the complete cognate set list of around 3,000 and something complete cognate set for Spanish, Italian, Portuguese, French, and Romanian. The results which we obtain when we apply on our methodology on each data set in part, we obtain, for example, for the data set of Bouchard, we obtain results in terms of edit distance with Ensemble 2.31. In terms of coverage 5 or coverage 10, we obtain 32. What means coverage 5 or coverage? We said, okay, maybe it's not the fair for us to use the computational tools and to say to linguist, to classical researcher, okay, this is the result and it's nothing to do, or okay, Eliana Pablo, okay. Maybe it's better to offer a list of 5 or 10 words, and the researcher, the classical researcher, to decide if it is useful or not. So this is what we said. We applied like when we decide to use this filter and to use the coverage field, the coverage 5. In coverage 5, this means that in the first 5 words which we obtain, we have it is true, our algorithm is true, okay, works well if the proto-word, we find the proto-word in the first 5 words here. If not, okay, is 0. For coverage 5, 10, if we are looking at the best at the 10 all the 10 the first 10 words. So here is the result for Bouchard when we apply on the orthographic and phonetic data or data of Bouchard 231 and 228. We obtain better results with Ensemble on phonetic data. We see here that in terms of edit distance, it's clear that Ensemble obtain better results than individually results which you obtain on each language in part, and the same is valuable also for the coverage 5 and coverage 10. When we move to the other two data set. On the data set of standard European with 1,000 words, we obtain the ensemble in terms of ensemble, in terms of edit distance, 1.5 okay difference, which is a good result. And for the coverage 5, around 50% for coverage 10, 55. But when we use the larger database, our database around 3,000 Cognates pair, we see that we obtain for the ensemble a difference one in terms of edit distance on almost 1 letter difference between our results and the real proto-word. In terms of coverage 5, we obtain 70%, and in terms of coverage 10, we obtain 74%. Okay, which is was very. It was also it was okay for us. What the results which we show we obtain on the database are okay. They have less values, but we want to see if our results are better than the results obtained by the Bouchard-Ecoute. And Bouchard-Ecoute obtained 2.34 difference in terms of edit distance, because they offer only the edit distance results, and our results was 2.28 in terms of edit distance. So actually, we obtained better results than the previously reported results on the same database. However, when we look at the results which obtain best our results on the largest data set, and we make the error analysis, we see that something interesting results we obtain in terms of error analysis. For example, mistaking the final consonant. In 5%, we obtain serenum instead of serenus. Our methodology said, okay, this is an error. But when we look and we talk with our colleagues, with linguists, they said, okay, it's not necessary error for us. Serenum, serenus is not clear if the word comes from serenum or from serenus. It's not clear if the word comes in a language from nominative or from accusative. Not here. Cantum instead of cantus. Novum instead of novus, and so on. So kind of error, this type of error we obtain. Another error which obtained and which was counted like error by us was the failing to double a consonant, intervallum instead of intervallum, essentia instead of essentia. Okay, double consonants, it is okay in the South Italy, but in the North it's impossible to pronounce the double. Obtaining F instead of PH, asphaltus instead of asphaltus, maybe was a convention, it was not clear. Euphonia instead of euphonia. Obtaining the ending a instead of as, citrina instead of citrinus, alba instead of albus, feminine instead of the masculine. So this the error patterns we obtain, they are counting like error. And when we talk, okay, with the linguist, with the classical researcher, they said, okay, look, for us, if you give us the filter of the first 5 words, for us it's okay, because we know how to work, how to cope with this kind of tip. And we don't consider them like error, but it's useful for us. So if we don't take into account this kind of error, probably in the next time we'll have another accuracy here, a better one accuracy. This was the results which we obtain. If I have a few minutes, if I have, I can stop here, but I can show you in no more 5 minutes. If I have, I don't know, Doris.
Yeah, go ahead. Thanks.
Yeah, because then we try to apply the same idea to more practically results and really results. For example, the first application was to automatic reconstruction of missing Romanian cognates and unattested Latin words. You know, probably it's not only the case of Romania, but it's the case of all the Roman languages, but not only for Romance languages. Okay, to have words which they have Latin ancestor in all the languages, but exceptly in Romanian there are no. For example, Belus, there are Latin ancestor in Italian, French, Spanish, Portuguese, in Romanian. No, to love, which is I like to use to love, you be ama. They have a Latin ancestor in all the other Romance languages, but in Romanian, the ancestor of IUB then is a Slavic one. Is a Slavic. It's not easy to see. Okay, that before the Slav, they don't know the they don't know the love and the word and so on and so on. There are we found around 200 Latin words that were inherited on Romance languages, but not in Romanian. We have, for example, a Slavic etymology for that language, for that word, and is the same in all the other words. Actually, they use the modern form, but not the Latin form. And we said, okay, it is possible to use the same strategy which we see before to find a form to see how maybe was that word in Latin. You know, okay, you can accept or not this, but at least like a joke we can try. It was the same idea, the same strategy, but for this time we work with pure etymologist, probably one of the best Romanian etymologist, Viorel Guruianu. Okay, I think for a lot of people. Okay, and he was completely skeptic before. I said, no, I work only with classical. But when he saw the result, I said, wow, but it's impossible. It was unbelievable. I can see that you obtain with your algorithm something, and the results which we obtain. And there was a huge discussion. The discussion was very nice. Our friends, you know, the linguists, they said, okay, we have to split your results in 4 or in 5 classes. Real words, so you obtain exactly the real form, which I think the real, the non-real, which is almost real, but with some differences, small differences. Virtual, maybe it was, but never we haven't solution. Now it's virtual, and no way it was bullshit. What way you obtain was a trash. And the results which you obtain are given here. We obtain a kind of from all the 2030 words. We obtain 82 real words, 12 non-virtual, and so on. For example, the words which we obtain are listed here. Here are the example of words. Okay, so they are not in English. For example, for to love, amare, we obtain the word ama for the Romanian way, which was before the Slavic words substituted the words, and they said, okay, this look nice for me. Other forms which we obtain are here, and they said, okay, there are no way, we have no evidence to accept this. What do you obtain? So we have for the moment these results with the form, the Romanian form before the Slavic come. The other one was to look to unattested Latin words, because always we have they use the attested Latin words only for words with historical evidence. If there are no historical evidence, they said, okay, that the words we cannot talk about this type of words, this Latin words. And I said, okay, that with asterisk with star words. And we said, okay, let's try to see if we apply our method on the words, okay, with Romance, with modern forms, and it is possible to obtain the words which were reconstructed, okay, in laboratory via comparative methods by the scholars in this, which work in this domain, by the researcher. And we obtain. The problem was that when we apply the same, we obtain accuracy only about easy, lesser than 40% top 10 accuracy, which is a little bit different and was surprising for us because before, when we apply the same on real words, okay, we obtain 70%, and a possible explanation, but it's nothing clear. Is okay, it's just a discussion. Maybe when the words were reconstructed in laboratory, they use more rules, and maybe sometime the human languages, okay, they use not so strictly rules, and they work not in a deterministic way, and could be maybe there are more, okay, more research and more intellectually forms of our, but it's not clear. Or maybe, of course, could be that we have to work more with our algorithm. And the last, and I finish now, the last result was to see if we can obtain, when we have a cognate form, if it's easy to obtain a cognate form of a word given their form in one language. So if we have, for example, the forma, the pairs millenario, millenar, okay, in Italian, if we have the millenario form of words, okay, it is easy to obtain the millenar, the Romanian words. And here you can see that we obtain millenar on the first position, but from Romanian to Italian, when we try to obtain, okay, we obtain on the fourth position. For Romanian Spanish, if we have the pair of words, we obtain the same word on the first position. For Portuguese, hypnose. For Turkish, autocracy, autocracy. And the result is nice to see here that via our methodology, when we have a particular type of words, the pair of words, namely cognates, we obtain the real cognates with less than one letter difference in terms of edit distance between Romanian and Spanish, and the one letter and something for Romanian and the other one. The coverage 5 is 70%. We'll see here from Spanish to Romanian, or from Romanian to Spanish, the results which we obtain. That's something it is easier to obtain the words, and if you don't know the real words in the language, maybe you have an idea that they are cognates. If you use your languages, there are a big chance to be understood by the other one, the results which obtain. Also, the last results, the borrowing generation. If we looked at what was nice. We looked at the etymology, at the dictionary, at the Romanian dictionary, and we have a full map of etymologies of borrowing from Romanian, and we try to see if it is possible to obtain the etymology of Romanian. What was nice here, it was nice that in this way we try to apply on 40 languages. The best results which obtain are not grouped on the phylogenetic way, on the phylogenetic relation. So the best are not with Spanish, Portuguese, French, Italian, or like Romanian in Roman languages, but were grouped on the cultural relation, because we're big relation between Romanian the languages and with English modern, with French, Italian, Latin, Neo-Greek, Slavic, Old Slavic, okay, was the French or the English in the 17th century, German, Turkish, and so on. And for example, in the Spanish, when the cultural relation between Romanian and cultural starts, I don't know, later, or when the Romania came, we obtain not so big results. So actually now I finish small conclusion which I talk some remarks. Our project is work in progress. I didn't talk about the semantic divergence, but I don't know if Anna is here. She always can talk some of results. Okay. I want to thank you to John to Doros for invitation, for all some in the brewery of Doros in the Oxford at ITHL. Okay. Thank you if I wrote well. If I use one. Okay. Thank you very much for your attention and for your patience.
Hey, thank you very much. So yes, we have time for a couple of questions. Has anything, or maybe I'll go first. So one interesting thing is you saw that the use of the sort of the true phonetics as opposed to the orthographic form doesn't seem to improve performance, which is something we've also observed. So was that using IPA phonetics or?
Yeah, we use always, because we start with orthographic forms. Always we start with orthographic forms. Was actually was a decision for us, because we said, okay, at the beginning we said, okay, it was maybe especially for Romanian or other, it was not easy to compare, to use the phonetic, and we said, okay, let's try to see if we have results, we have something, and then probably there will be difference, but not so big. And our surprise when here when we apply, and now we want to apply also the same methodology and on the orthographic forms. Here, when we apply for the discrimination between inherited and borrowed forms of the words, and we use the orthographic and the phonetic form, in a way that our intuition was here. The were not so big differences in the results which we obtained.
Yeah. So one thing we found is that the use of IPA is basically just too fine-grained. There's just too many symbols, and there's too many things like stress markers and such like, and kind of small differences which actually get in the way of detecting cognates. So we kind of found it, if you simplify the phonetics a little bit, it works much better than if you use sort of the IPA directly. Yeah,
in a way, there are languages, for example, maybe in the particularity of languages, because we use the Romance languages, and in Romance languages, more or less Romanian, Italian, in a way Spanish, they are more or less, they are orthographic languages. And for French, for example, because we use here only the pair Romanian French, not French, and the Romanian one borrow from French, they borrow the especially the orthographic form of the word, not the phonetical form of the word, like I was, for example, for the Turkish borrowed the phonetical form of the word. But especially when we work with this is our probably next we want to use to see really the differences to see. Yeah.
Okay, thanks. Are there some other questions?
See that Mark Darling has his hand raised. Good to see you, Mark.
Okay. Hi, Mark.
Hi.
Hi.
Can you hear me?
Yeah.
Brilliant. Sorry, I sometimes have trouble with the sound on the computer. It was just a small comment about the failure to identify the final consonants for the Latin reconstructions. And of course, those consonants are largely lost already by the 3rd century in Latin, at least in some dialects. So I think your chances of reconstructing them accurately for your final S and final M are going to be pretty slim anyway. So you probably shouldn't be too discouraged by that. They're not there, so they don't survive into proto-romance, if you can call it such a thing. So I think the fact that you're not getting those entirely right is probably not too bad a thing. So yeah, that's the extent of my comments.
No, that's okay. Definitely, we need more comments on our results. More comments and more deeper comments and analysis, because we said, okay, this is our results. Okay, we have some idea, but definitely, and to see, of course, if maybe the words which we obtained, the proto-words which we obtained, maybe it was I don't know, some naive words, some so simply, or maybe it was too difficult, because and here is exactly what I said, and Doro said from the beginning. We want computer assisted by computer, and always, because we have I don't know if it is here, we have a very nice friend which work, Laurentiu is a pure linguistic, and always there are so many discussion and so very nice discussion, but it's not time to add here. I completely agree, because in a way this is a tool offered by computer scientists, but not for computer scientists. It's a tool made by computer scientists for, I don't know, for you, for the classical researcher, because if it is okay, something maybe.
To me, it seems like a pretty cool way to recover some of the vocabulary that would have been going around in non-elite Latin, which because that's presumably some of the the things which you don't have tested in classical literary Latin, which survives into Romance. This looks like it might be a nice way of recovering some of that. So that's pretty cool. But yeah, it's nice work. Thank you.
Thank you for comment.
Hey, right. Joyce, you want to ask
quick one, if that's okay?
Yeah, go ahead.
You made a distinction between inherited words and cognates, but I'm still not sure that I completely understand the difference.
The difference between inherited and borrowed word.
Between inherited words and cognates.
I made a distinction between inherited and borrowed, not from cognate.
Okay, sorry.
I made the distinction. It was the distinction between cognates and borrowing. And then the distinction between inherited and borrowed here, because between inherited and cognate there are no. Borrowing and inherited.
Okay, sorry. Yeah, okay.
Yes, because here I leave a little bit. I explained it because was.
I think it was at the beginning of the presentation.
Yes.
Yeah. Okay.
You're right. No.
Okay.
Yeah.
Thank you.
Thank you.
So I have one final maybe question or comment. It's fascinating, this ability to rebuild these Latin forms. Have you thought about taking it further and trying to say reconstruct Proto-Indo-European forms or something?
We think about it, but we talk always. They are behind us. Okay, the problem is. The discussion is data, because now I am confident with the methodology, and if we have data and if we have to work, probably we will be okay. We have to try, because I have no idea if it works or not, but we have to try, or always on other language families, and for Indo-European, of course, always is the same. At least to try to see. The problem always will be the data, and Yes, and the data and something. Okay, you know the relation because it's,
Yeah, it's certainly fascinating. It'll be very interesting to try. Okay, great. So if there's no other questions, I'd like to thank our speaker again.
okay.
And our next seminar and the last one of the year will take place in about a month and will be announced soon. Okay, thank you, Professor Dinu, and thank you everyone for coming.
Thank you, John. Thank you for thank you for the invitation.